Hi, in heap, till now I discussed introduction to heap, max-heap, min-heap, max-heapify, building a heap and heap sort. Let's discuss some more important points about heap. In case of max-heap, root contain the maximum element, whereas in case of min-heap, root contain the minimum element. In max-heap, to find maximum element, running time is theta of 1. We know it's present at root, we can just pick the root and it is theta of 1. So what's the running time to find minimum in case of max-heap? Minimum element can be present in any of the leaf, and leaves are not in sorted order, so we cannot apply binary search. We need to apply linear search on leaf. And how many elements are in leaf? There are n divided to ceiling function elements. So on that we need to apply linear search. There will be n by 2 ceiling function minus 1 comparison. So for this much comparison, running time will be theta of n. This is a max-heap. Root contain the maximum element. So for finding minimum element, we need to do linear search on leaves. There are 4 elements on leaf. First we'll compare 8 with 7. 7 is the minimum. Next we'll compare 7 with 1. 1 is the minimum. Next we'll compare 1 with 4. So 1 is the minimum. There are total 3 comparison. So for 4 element there are 3 comparison. For n by 2 elements there are n divided to minus 1 comparison. That's why running time is theta of n. Same for min-heap also. In case of min-heap, finding minimum element running time is theta of 1, while finding maximum element running time is theta of n. We need to search on leaves, and there are n divided 2 elements are present on leaf. On that we need to do linear search, so it is theta of n. So number of comparison required for finding minimum element in max-heap and maximum element in min-heap is n divided to minus 1. This was asked in a previous question. So just remember it, n divided to ceiling function minus 1. And running time is theta of n. Next, how will arrange the elements? Kth smallest element in a min-heap cannot go deeper than level k because the path from root to that level goes through k minus 1 smaller element. Suppose some elements are given like 1, 2, 3, 4, 5, 6 and 7. And we want to find third lowest element position, means here 3 position. We can design min-heap like this: 1, 2, 3, 4, 5, 6, 7. So here 3 position is at second level. Also you can design min-heap like this: 1, 2, 5, 3, 4, 6, 7. Here 3 position is at third level. So kth smallest element, here 3 is the third smallest element, cannot go lower than third level. Same for max-heap also. Kth largest element in max-heap cannot go deeper than level k because the path from root to that level goes through k minus 1 larger element. Next, application of heap. Heap sort is one of the best sorting algorithm that uses heap. Here running time is theta of n log n. Next, priority queue. Priority queue can be implemented by using heap. Next is graph algorithm. Especially Dijkstra's shortest path and Prim's minimum spanning tree uses the heap. Next I will discuss difference between min-heap and max-heap. In case of min-heap, parent value is always less than or equals to its child, while in case of max-heap, parent value is always greater than or equals to its child. Next, in min-heap, root contain the minimum element, while in max-heap, root contain the maximum element. Min-heap uses the ascending priority while max-heap uses the descending priority. In case of min-heap, running time to find minimum element is theta of 1, while to find maximum element is theta of n, as maximum element is present somewhere in the leaf. In case of max-heap, to find maximum element, running time is theta of 1, while minimum element is theta of n. Minimum element is present somewhere in the leaf and we need to apply sequential search. Next, in min-heap and max-heap both, running time for insertion and deletion is theta of log n. Let's see one example of min-heap. In min-heap, root is the minimum element, while in max-heap, root is the maximum element. And in min-heap, parent value is less than or equals to its child, while in case of max-heap, parent value is greater than or equals to its child. With this, I am finishing heap. If this lecture is helpful for you, please like and subscribe. Thank you.